The concept of an elementary flux mode is that a minimal set of enzymes, or in other words reactions, that can operate at steady state. It can also be thought of in terms of the smallest subnetworks that allow a bionetwork to function at steady state. Also, you can think about it as a minimal combination of reactions whose combined effect maintains the network in the steady state. Now, elementary fluxes offer a key insight into the objectives of the network. Each elementary flux mode should have a clear biological interpretation in terms of the objectives of the network. We should also determine whether a given set of enzymes or reactions are feasible at steady states. Larger flux modes can be obtained by composing several flux modes, and that will determine the so-called steady-state flux distributions. We are interested in linear combinations of reactions whose combined effect is to preserve the steady state. This is what's going to give us the elementary flux modes. So, if we denote by Wi the weight of reaction I in the flux mode, recall that ds to dt equals n times v, where n was the stoichiometric matrix and v was the vector of fluxes or reaction rates. So we are interested in combinations of fluxes v1 all the way to vr that ensure that ds to dt equals 0. So in other words, what we need to do is to solve the equation n times w equals to 0 in the unknown w. And recall from linear algebra that the solution is called the kernel, or the null space, of matrix n. In general, the solution is the vector space, and we are interested in its base. All other solutions are linear combinations of the elements in the base. So here is an example. We have 4 reactions, the first one being that S1 is both degraded and created. Then the second one, S1 goes reversibly into 2S2. The third one is that 2S2 goes into nothing. And the fourth one, S1 goes into S3 in a reversible way. So the stoichiometric matrix is the one shown below the list of reactions. And the kernel can be determined to be 1, 1, 2, 0. Now, V4 equals to 0 means that in any steady state, the rates of production and degradation of S3 must be equal.